I was born in the center of Amsterdam back in the 80s when it was a bit of a chaotic city. Being a dyslect, I was interested in anything but school. I was always interested in engineering, the galaxies and the stars and all the physics behind that, but I'm not theoretical. So I studied mechanical engineering, did a master's in sustainability and a minor in thermal engineering, and that's how I rolled into this field.
Why is heat waste a problem in computing?
All the energy that goes into a server becomes heat. You're throwing away heat with air conditioning that could be reused. Yet it's something hardly anyone talks about. And what cooling it means is it costs you energy to throw energy away. I don't think that throwing away energy is efficient, not even if you buy green energy in Norway. If I put a space heater in a field and I power that space heater with green energy, would you say it's a green space heater?
No.
That's what a data center is. It's a space heater in a field. Once you're growing it to significant percentages of the global energy demand, it becomes an issue. About 5% of the world's emissions come from software. That's more than flying, shipping, and trains combined. AWS is spending billions a month on their infrastructure. They are buying old nuclear power plants and repurposing them. These are very expensive ways to host servers. So now we are in a situation where energy prices for households are skyrocketing because data centers pay very well for their energy. Google, Amazon, Microsoft are sort of in collusion. There's many great people in those organizations that want to make it greener, but you've also created that beast, and that beast is the internet running on coal. So what we do, we put servers where heat is needed. Elderly homes, swimming pools, apartment complexes, places that need heat 24/7. Same thing goes for a data center, needs cooling 24/7. They get hot showers for free in exchange for a free place to put our servers. A server cools via the boiling of that liquid. And that's how we've reinvented the way to build a data center. It's a distributed data center. If you put all the currently installed data center power in the Netherlands and you transform all of that into hot tap water, 50% of all showers in the Netherlands will be free.
How foundational is the problem Leafcloud is actually solving? Would it not make sense to make more heat-efficient GPUs than to just work out how to repurpose the heat better? Hello, and welcome back to CleanTalk, the podcast shining a spotlight on inspiring companies and professionals across the world of renewable energy and clean technology. I'm Luke. I run Harmer Visuals, a film production agency working with companies in the renewable energy and clean technology space to enable climate transformation through data-driven storytelling. And the way we normally do that is through case study and brand films. Today, before we start it off, I just want to give a big thank you and a shout out to Matthew Davies, Head of Engineering at Genome Key, who suggested that we look at the relationship between renewable energy and the energy demands of the IT industry. Thank you, Matthew. Today, I'm in Amsterdam. We've gone beyond the UK once again, and I'm here at Leafcloud, where we're going to be chatting to David, who's the founder, about what their company does and why it matters for the future of our energy needs and our computing needs. David, thank you for joining me today.
Thank you for having me.
David, can you give me a background on sort of who you are, your early life? Paint a picture for me.
I was born here in the center of Amsterdam back in the 80s, and when it was still a bit of a chaotic city, lots of drug use here. My father tried to purchase a house in the city center. The bank wouldn't allow it because it was too much of a gang. This is one of the most expensive parts of Europe right now. So that's how much has changed in the meantime. I grew up in Amsterdam East, which is a very nice, dynamic neighborhood. Lots of influences from all over the world. Yeah, that's where I come from in early life.
When you were at school, what were you interested in?
I wasn't interested in school.
Okay.
I was interested in anything but school. Building stuff, building remote control boats and cars and planes and playing with my friends and Legos, and that was what I was into. But school didn't provide that. I really did not enjoy it. Being a dyslect, this tends to be the case where you are forced to learn things, basic stuff that doesn't interest you that much. Where a lot of other stuff interests you a lot, but that's not what you're busy with at school. So it's a bit tough there.
Yeah, and did you find that being dyslexic helped in some ways that maybe you didn't appreciate at the time?
Oh yeah, now of course. Yeah, but when you're going to school, those tools don't get tested or measured, so you can't excel at school in that sense. Yeah.
Talk me through beyond school, early career, those first experiences.
After high school, I was like, no, I'm not gonna study. I saw my friends, going to university and then being there for a year, flunking out, or realizing that they come to the wrong choice and being left with some student debt. And I was like, no, I'm not going to do this. I don't have the patience for it. And I know I'm going to flunk out. So I didn't do it. I just went to repair bicycles, as I did during school days already. And I did that for about 10 years here in Amsterdam. And I learned a lot from interacting with humans on every day, and then doing an interesting bit of sales. Bike repair is in a lot of ways misunderstood because you're selling repairs. Basically, every bike in Amsterdam has 200 euros of repairs in there, but they come in for a flat tire that they want to get fixed for 7 euros, right?
Right.
And it's your job to sort of ease in the idea of maybe doing some more. And it's not like you're selling bullshit. You're selling actual useful stuff, which is the bike that they're using every day to go to work.
Yeah.
Maybe you put a new chain on it and a fender and some lights, and it'll be safer, and it'll work better, and it'll be more reliable. This is an interesting bit of sales learning, where I did learn that trying to be too nice and trying to be too friendly on it can push back. So I did sometimes turn it around, where you have like a 25-year-old that finished his studies, is now working at his first job at an enterprise. It's pretty good pay, and they're still biking on their student bike. And you say like, well, dude, you're running around with 250 euro shoes here. You don't even want to spend 10 euros on your bike you want to use every day. I think you should shift your priorities a bit. And some people don't catch on it, but quite a lot of them really like it when they get challenged in their ideas. In sales, sometimes challenging your customer can actually make them come back to you rather than you sort of chasing after them.
Leveling with them, right?
Yeah, leveling with them, and not having this balance of power where you're asking them something.
Yeah.
You're also requesting something of them.
What was your own personal conviction on the sustainability front? It's become more interesting and more prevalent in kind of our cultural narrative, particularly in the UK, and in Europe. Europe is a testament to the UK in a lot of ways. Were you like driven on the personal level to make a contribution for a given reason?
Yeah, I just saw that in a lot of ways what we do isn't efficient. Typical Dutch stuff, we don't like cars, or we try to avoid cars as much as possible. So one of the things is like just a very simple equation where you say, okay, I'm using a 2,000 kilo car to drag my 75 kilo ass around. That isn't efficient, right? So this I've always had something against, and I think that's the core of it, where I see a lot of inefficiencies around me, and that's always been there, and that's what driven me to do the sustainability side of things, where you try to chase efficiency. So
beyond the bike work, where did you go next? What did you do?
After doing that for years and years, I was like, either I'm going to start my own business in the bike business, or I'm gonna study. And I was always interested in engineering and physics and science, and mostly like stuff like the galaxies and stars and all the physics behind that. But I'm not theoretical or patient enough to do theoretical physics or math or something like that. So I studied engineering. Mechanical engineering, with a lot of pleasure in a school in the south of the Netherlands, and the Windesheim. Shout out! Enjoyed that a lot. Did a master's in sustainability and minor in thermal engineering, and that's how I sort of rolled into this field in my internship.
Fantastic. Unpack that for me. So the master's you did in sustainability, is that a recently developed course?
No, that was already. This is like 15 years ago now, 13 years ago. So that was already something that they did back then. And we went to power plants, we went to solar plants, we went to heat pump manufacturers, and learned a lot. These sort of applied universities in the Netherlands are very hands-on. So they always were very like not that theoretical. There are lots of theory, but it's not only stuck in a theoretical sense. We really did see factories and how it all works, and how they're actually changing the world bit by bit there.
Before we get into your next career milestones, which revolve around IT infrastructure, I'm having more conversations with people like you around tech, which is great, but I'm not a coder, I'm not a developer, I'm not a computer expert. Can you break down, I guess, just in layman's terms for us, terms like data center, terms like server farm, for people that aren't familiar with those terms?
A data center is a place where you build a building, you put it full of servers, at least that's what your attempt is. But it takes about 8 years on average to build a data center. Why? Because of legislation. You need power in the ground. Power in the ground generally takes a long time because lots of people want power in the ground. We're electrifying the whole world. You need fiber in the ground. And then the first years you have it, 20% occupied. But your cooling system and all of your equipment is built to have 100% occupation. So the first year is actually very, very inefficient data center because it's meant for a scale that it's not running at. And after 5 years, it's maybe 50, 75% full, and it becomes somewhat efficient. But what they call efficient is the ratio between how much energy their servers use versus how much energy it costs to cool the server. And that's called the PUE, power usage effectiveness. On an industry average is 1.55. So from every unit of compute, every energy that computers use, you need 0.55 to cool it. And what cooling it means is that it costs you energy to throw energy away. Even in the best case, right, where we have a 1.1 PUE data center, where that's the most efficient data centers in the world.
Okay.
It still means you're throwing away 110% of all of the energy that comes in. And that's the most efficient data center in the world. It's interesting that you talk to software people, because in a lot of ways, software people don't even understand. Only infrastructure people understand. And there's a bigger gap in IT between software people and infra people than most people tend to make out. Most software people do not understand how data centers work. No idea. They turn on workloads on clouds, but how all that works in the back end, they don't know.
One more question to tee you up for explaining the next steps in your career timeline. Why is heat waste a problem in computing?
So let me ask you a question. What percentage of all energy that goes into a computer becomes waste heat?
I'm going to guess 50%.
And the other 50% becomes compute?
Yeah.
Compute is not a form of energy. So all the energy that goes into a server becomes heat. We compute on very fancy resistors. And the reason we're doing that is because we can't build fancier resistors. If we could, they would use hardly any energy, right? So there's no sort of physical reason why a computer uses that much energy. It's just because we can't build them more efficient than we currently do.
Right.
And that's something we've been making much more efficient already for the past 50 years, right? Or 20 years. Right now, we've got to such a scale where we're putting servers everywhere in the world to run compute on, to run software on. That's the basics of it, right? We want software, and we want efficient software that runs well, that works, that's useful to people. And we got into the situation where about 5% of the world's emissions come from software. That's more than flying, shipping, and trains combined. Yet it's probably something hardly anyone really talks about. We've started building data centers because we had sort of a mainframe in a basement at a large enterprise. And then as we went along, we put more mainframes in the basement of a large enterprise. And it turned out it became hot in the basement and became a problem in summer. And there were people in the building, which tends to interfere with uptime in general. People tend to break things. So we moved those mainframes to a building specifically made to cool and run mainframes. Now, mainframes is a sort of old-fashioned way of running software where your one application runs on one machine and isn't duplicated over many machines, right? So the uptime of that machine is the uptime of your application.
Okay.
Nowadays, we've gone to a world where software runs over many, many servers in distributed archetypes where the failure of one machine doesn't impact the uptime of the application itself. We still build hardware as if we run it on mainframes. We build data centers, build centralized silos full of servers that make sure that server stays up. But once you're growing it to significant percentages of the global energy demand, it becomes an issue where you're throwing away heat with air conditioning that could otherwise be reused. So now we are in a situation where we have data centers everywhere, and we say we need more data centers to put more compute. And yet, energy prices for households for heating their apartments are skyrocketing because data centers pay very well for their energy.
Right.
Green energy is well paid, much better paid in data centers than it is in households.
And so who are the culprits for this sort of thing?
Big tech makes a lot of money building data centers and scaling that. It's an industry that's having 20-30% compound annual growth rate for the past 15 years. $700 billion going towards $1,400 billion in 2030. This is a massive industry that's shown really great progress in terms of financial development. So of course the finance rules. So it makes a ton of sense that you're using a strategy that works because you know it works. And if you're running like a middle upper management at AWS or GCP or Azure right now, you'd be silly to change course.
Sure.
Because you're racking in the dough, right? So they don't change course. And that is the core of an industry that's growing so fast. And there's no real competition in a lot of sense.
We've got kind of a monopoly from Gugamasoft, is it?
Yeah, Gugamasoft. We try to call them as it's
Google,
Amazon, Microsoft that are sort of in collusion in this industry. Yeah.
And their approach to things becoming truly efficient just isn't a priority for them.
It's typical, right? You've created a beast. I think there's many great people in those organizations that want to make it greener, but you've also created that beast. And that beast is basically the internet running on coal, right? We could use that waste heat, but it's just not done because it's not the way we're operating.
Let's unpack that a bit further. So just because someone says they're using green energy to power their needs doesn't mean that they're sustainable as a whole.
If I put a space heater in a field and I power that space heater with green energy, would you say it's a green space heater?
No.
Nobody needs it, right? And that's what a data center is. It's a space heater in a field. We need the compute. We don't use the heat, right? And that's a byproduct that's currently just being discarded. I don't think that throwing away energy is efficient, not even if you buy green energy in Norway. And I think in a lot of industries that's something that's going on where they claim something is green because you use green energy. I mean, the same thing like purchasing green energy for your home and then having your house at 25 degrees all day. Yeah, that's not that effective. So I think we need to challenge that a bit more. And that's something where, thermodynamic people are often the ones that say, hey, wait, that's not that effective.
You graduate from your master's. What's next?
I was looking for an internship and I found an interesting article in a big Dutch newspaper about a startup in Delft that was doing putting servers in people's homes. I was like, that's cool. And I was always building computers for my friends and my family, and I was into sustainability. So I wrote them a bit of a naughty email saying, I'm a sustainability nerd. I'm a nerd in general. I really like what you guys are doing, and I think you need me. Let's go. So just very short and to the point. Let's please have a talk. I'm looking for an internship. Directly got a positive response from their CEO. And we talked and I got hired for an internship as a thermal engineer building an immersion cooled hardware setup, which means you literally dump a server in a liquid where it starts boiling and then it cools via the boiling of that liquid.
And was that cutting edge technology at the time or was that kind of established?
Yeah, so that was fully cutting edge. Everything they did was cutting edge. They really did very complex way of running a startup where you want to do the full 100% in one go, right? So the market is here, and let's say you want to aim it to be at point B in 10 years' time. Instead of sort of slowly changing it, they wanted to do a leap to where the market would be in 10 years.
Wow.
On every front. So that means on the hardware engineering side, but also on the software engineering side, where they did a fork of a not that popular project. They did their own booting system, their own encryption system, their own storage system. So needless to say, it was too complex and took too much time and therefore failed. In December 2018, everything came to a halt after a combination of failed investments. So one investor pulled out at the last moment while they were jumping in with multiple investors that also pulled out because of that one investor pulling out. So it was a really shitty situation for them. That led to two guys being burned out from the founding team.
Why do you think it failed? Because I was speaking to someone called Anne Buckingham. So she's the managing director of a company called eVolt Charging. Shout out to eVolt Charging again. And one of the pitfalls she was saying of a lot of startups in the renewables and sort of tech scene is that they go in with a proposition that's way too technical to get any market traction, Was there any of that involved?
Yeah, for sure. It was a very large team, and everything about it was deeply technical. In such a way that you're sort of building a product, a cloud product. Let's be real here. That is a beta on a beta on a beta, right? So you're trying to sell something that is really stable, secure, needs to be up, has like enterprise style requirements. That's the market. You're pitching something that has none of that at any level. Whereas if you have it on some level, you use a massive open source project that almost everyone in the market uses, then maybe it would have worked. If at some level they would have changed the market, and on other levels they would have adhered to the market, it would have worked. But this mix of really not adhering to the market on any level, that was finesse.
Is part of it, if you're trying to appeal to the market with the most intensive needs and demands, there's no room for failure or no room to sort of like iterate and scale your product up?
I think there is, but you have to be really smart at where you do that and where you don't. And that's, I think, what we've tried to do in the past years is really trying to minimize the risks while trying to maximize the way we are more efficient and more cost effective than the rest of the market.
You did the internship. What was next? I mean, we're sitting here today at a company that you founded and own, and I guess I want to bridge that gap. Like, fill me in on the rest of the journey.
An investor purchased what was left of the company after its bankruptcy, and he contacted the founders and asked them, would you like to continue? What happened? How can we restart this? So these founders said, well, maybe you should talk to David. So I talked to this investor, and I was like, hey, this is a cool guy. He knows, he understands what's going on and what we're doing. We talked for a bit, and I had the idea of rebooting it, but really trying to simplify, try to make sure that it's a feasible approach where we focus on the sustainable cloud stuff, but make that as simple as possible, as feasible as possible. So together with him, we rebooted the company. I locked myself in a workshop for about half a year, sort of challenging every assumption that the startup before that, Nerdlize, did in every sense of the way. Like every assumption they did, really double check: is this the case? Is it the case that we need immersion cooled hardware to reuse waste heat? Are there other ways? Or how effective are they? Okay, turns out there are cheaper and more effective ways to do it. Same thing with the entire building cloud in the first place. Like, were they using the right project? Why weren't they using the largest public cloud open source project in the world? And figuring out a bunch of stuff as I went. And then with enough information and enough grounds to get started, we started hiring a team. What we do, we put servers where heat is needed. So think elderly homes, apartment complexes, swimming pools, place that need heat 24/7. The same thing goes for a data center, it needs cooling 24/7. So there's quite a natural relationship in there. So we put a rack full of servers there, a way to extract the heat. That can be water cooling, immersion cooling, or heat pumps. Give that heat to the apartment building or to an elderly home, and then they get hot showers for free in exchange for a free place to put our servers. That's the core of our business, is this exchange where there's basically closed wallets, and both have a massive benefit on each side of the equation. We get a free place to put our servers. We get a place where fiber's already in the ground. They get free heat, and we pay, of course, the energy bill. We're putting it near where people take showers, so we can literally put it in an elderly home where we're delivering hot showers to the elderly there, with the AI workload of a startup in Singapore. And that's a really fun way to do it. And so the idea is very simple. We put servers where heat is needed, make a distributed archetype on it that sort of mirrors the way we built our software, where they're spread out over multiple sites, spread out over multiple computers. And the uptime of one of those sites isn't critical for the application itself. And that's how we've sort of reinvented the way to build a data center. It's a data centerless data center, distributed data center. If you just translate that into, tangible numbers, if you put all the currently installed data center power in the Netherlands, it's 4% of all power in the Netherlands, and you transform all of that into hot tap water, 50% of all showers in the Netherlands will be free.
Wow.
Now, this is the Netherlands. Ireland has 21% of all electricity going to data centers.
That's because there's loads of companies registered in Ireland, right?
Yeah, it's a massive issue there. So Ireland could be heated for free, all of it. Like all the buildings, all the hot tap water would probably be able to be delivered for free by all the data centers in Ireland.
That's fascinating. Companies with a good employer brand do a lot better at recruitment. You know, if you're pitching, you can make a good contribution to an industry that's vital. You know, people want to sign up, or at least they should. Was it easy to hire?
Well, I have a pretty genius friend of mine that I wanted to do something with for a long time, and we were always trying to find if we could start something together. And he didn't have experience in the field, but we all knew he was smart enough to do it. And so we got him aboard. Then there was one guy from the old startup Nerdlize that used to work there. That I always thought that was pretty good and pointy in some of the things he said. So contacted him. So with this 3 founding team, we restarted. Via we got a genius network infrastructure engineer, hired him as well. And with just the 4 of us, we've built a cloud provider in about 3 to 5 months, and got a client running on it, got servers in places where he is needed, built a front end, built a bidding system, and got started. Keep it simple, stupid approach, as short and tight as possible, rather than trying to do, sort of the 80-20 approach,
sure.
Rather than doing the full 100% in one go and then failing at it because you realize doing the last 20% took a lot more work than you thought it was.
What did you need to build hardware and software wise, and how did you get a flow for doing that and overcome challenges at the start?
We needed a way to put servers in a location where heat was required. So we found that through a partner called ATEC Energy Systems, and they basically have inside of apartment complexes, they own and operate heating systems. So we partnered up with them to deliver waste heat to one of their apartments. Then we built a system of water-cooled servers to deliver the waste heat to that location. So this was just off-the-shelf hardware that we cobbled together to make a water-cooled rack. Using a bit of tricks, we got that water to 60C, so it was delivering 60C water directly off the server chips. Then we built OpenStack, which is a platform on which you can provide cloud. That's an open source platform built by IBM, NASA, large cloud providers, very large corporations, Red Hat, all over the world. So this is a very mature platform. So we took that off the shelf and installed that. Then we needed some basic stuff to do billing and a client to get started. And once we got 3 of those things together, we executed.
You found a partner that was a heat manager for a building.
Yeah, for buildings. Yeah, lots of buildings all over Netherlands.
And you were installing server farms, sort of decentralized, small chunks of them in there.
Yeah.
How foundational is the problem Leafcloud is actually solving, though? Would it not make sense to make more heat-efficient GPUs than to just work out how to repurpose the heat better?
Under that lies an assumption that making chips more efficient would mean that we'd use less of it, or we'd use less energy for it. Now, we've been making chips more efficient for the past 30 years. And that's nearly double the efficiency every year. Yet we're using more energy for compute than ever. So I challenge that assumption that making the chips more efficient would make it use less energy, because under that lies what's called the Jevon's paradox, where making something more efficient actually makes it consume more of its primary resource rather than less. And there are some very basic examples of that, right? You have a 2-lane highway that's always full. Turn it into a 5-lane highway. 2 years later, the 5-lane highway is always full. You just created a way of making more cars take that trip. Same thing goes for LED lights, right? We've created a much more efficient way of making lights, and yet we're using more energy for lights than ever. Why? Because the business case of putting lights on buildings, and it's so much cheaper and so much easier. You don't have to think about turning it off, because why? Costs don't matter, right? So AI, for example, is a great example of a Jevon's paradox, where we've created the most efficient way of asking a computer a question in a very wide solution space, where we don't have to go through all the options. We sort of can get a mastered response from an AI that will give you a very good response that is very near with what a human would say to that. Because of that, what happens? How often have you asked computers questions 2 years ago?
Not as much as I do today.
Yeah, you're asking computers way more questions, right? So if you could hire an AI that would do your job just as good as you do, how many would you hire?
As many as I can.
Yeah,
I suppose.
yeah. That's the underlying aspect here. When we're going to making computing more efficient, we're going to do more compute. Knowing that, we'll probably use more energy for compute. Even if we're going to make them more efficient, we should still solve that first issue, what to do with the heat. And right now, the answer to that has always been build more data centers because we need more data centers. No, we need more places to put servers. Data centers are the current best option for that, but we're trying to change that. And then, you know what? You could build a heat net on a computer, or sorry, on a data center.
A heat net.
Yeah, so just pipes in the ground where you pump the heat around. You give it to buildings or industries or greenhouses. And then you look into publications about that. And the answer is always, you could do that, but its return on investment would be around 50 to 100 years. So nobody does it.
Right.
Because the business case basically would be, you build a data center and then you build a heat net. Both things are expensive. What we're doing is we're putting those servers where the heat is needed. The building is there, fibers in the ground, power is in the ground. The cooling of our servers, aka the heating of the building, already exists. So I don't have to build anything. I just simply have to put a rack of server and a way to extract the heat and give it to the building. I don't have to pump up the heat from 35-degree airs to 120 seawater like I'd have to in a heat net. I can deliver them 35 to 55-degree water, which I can do with off-the-shelf equipment. It's very, very easy. So this sort of reverse approach to that makes both economic sense, but it also makes a sense in where we're actually doing something useful with the waste heat. And it's something that can be scaled up massively because heat demand worldwide will always be bigger than IT demand.
Does the fact you don't have to build the heat networks mean you've got more money to spend on more important things?
Oh yeah. It's like a 10x difference per watt of installed IT. That what we're doing versus building a data center and a heat net. It means I can buy more computers and I can build better software and build better managed services. AWS is spending billions a month on their infrastructure, and they're buying old nuclear power plants and repurposing them and building more data centers. These are very expensive ways to host servers. And in the end, what we're doing is we're building like this insane stack of redundancy, right? So you have the building that has redundancy levels, the cooling that has redundancy levels, the servers that have redundancy levels. And then on top of that, we have the software industry that is building another layer of redundancy levels and another layer of redundancy levels. In the end, we're living in a world where, you know, that video you once made when you went to Mallorca and you videoed the car that you rented to make sure that there was no scratches on it. It's a 300, 500 MB video, but that's probably duplicated 15 times. Somewhere in that region, if you really would go into it. Do you need that video 15 times?
No.
This insane stack of redundancy we've built is something that we need to sort of look critically on. And we're providing a service that is just as up as what the big guys are doing, right? It's 99.9958. So we're going towards the fifth nine. And yet we're doing that with way less resources than they are.
Legislation impacts how fast tech and renewable energy can be deployed at scale. Is there any advantages or disadvantages of being based in the Netherlands you found in building this business?
There's a couple of advantages that we have that allow, for example, the waste heat of those servers to be accounted to the building, but the energy use of that service isn't accounted to the building. That's a useful legislation where the impact is high for the building to use our waste heat. The other one is that there's amazing fiber infrastructure in the Netherlands. Us being a entrepreneurial company that wants to distribute stuff to the rest of the world, fiber is I think something that we understood fairly quickly the value of, and therefore we have Amsterdam Internet Exchange being one of the biggest internet exchanges in the world, and there's fiber infrastructure almost everywhere in the country. That helps in getting things started. It's a good proving ground for technology like this. There are also pretty big downsides to running in the Netherlands. Us being such a trader nation, we don't really care if we purchase it in the States or if we purchase it in Russia, because we don't have the idea that we'll ever do everything ourselves, right?
Okay.
Whereas France and Germany and England, to a lesser extent as well, they are sort of having a background where they wanted to be able to do everything within the nation.
Right.
So because of that, they are much less comfortable purchasing things in America, purchasing things in Russia, in Qatar, et cetera, et cetera. And that's what you really see with German legislation and German way of thinking, where they think European cloud and sustainable cloud is something much more important for enterprises there than it is here, where enterprises have this idea of, our cloud strategy is we do everything on AWS. And that's it. So we have, I think, an infrastructure upside here in the Netherlands, but a mentality downside where they don't mind purchasing everything on Americans, where we think that putting critical data, sensitive data on American servers is an issue, because there have been many court cases that have shown that the American Central Intelligence Agency can access your data if they want to. That's something that I think we should try to avoid in Europe going forward. Really try to hold things within our borders a little bit more than we've done in the past. Something that governments tend to do is they want to learn from the market.
Okay.
And then the market tells them what they want them to know. And then the government applies what they've learned from the market. But what the market has learned them is what they want them to know.
Yeah.
I generally think that governments don't do enough research on their own and don't listen well enough to universities, to the scientists behind it, that they might claim some other stuff, but they're not the ones reckoning in the dough. So they're not the ones that get listened to. And that's I think the at core here.
Okay. So like more independent research from the government.
Yeah.
Okay.
In the Netherlands, we have like a limit to how much money you can make in the government, which means that the best talents go to enterprises, and we can't compete on talent in the government. And I think that's risky. I think that makes the intellectual prowess at enterprise too big versus the intellectual prowess at government, and that imbalance in ways.
Okay, so you're saying that there's a limit to how much the government can pay for people in these fields as opposed to the commercial.
I mean, how many technical people work at the government? It's really in our government. I don't see it. I don't see politicians with a technical background. They hardly exist.
Leafcloud's offering is in no small part targeted at AI development companies. Do you have any fears about AI?
In its current form, no, not really. And that's just a very practical sense of, I'll just pull the plug, right? Even if it goes wrong in any way, we still control the power. We still control the cables in the ground. There's no AI running power stations and solar power plants and et cetera, et cetera. So the power side of that is often, I think, misunderstood. And even if it goes wrong, we'd still control the power, and we just turn it off and shut it off. The efficiency of AI is sort of measured in how much tokens a second per watt something can output, but does it actually give useful answers? When you ask a question and it doesn't have enough information to properly answer it, does it tell you, I'm sorry, cannot answer this. You didn't give me enough information. ChatGPT tends to just shoot it out, right?
Is it hallucination? That's what it's called.
Yeah,
right?
I don't know if it's hallucination. It just wants to answer so badly. It's like I always compare it like it's a stubborn teenager that's read the entire internet, but actually doesn't know anything about actually doing stuff, right?
Yeah.
And that's it wants to prove so badly that it knows something. Where I think like AI should be maybe a bit more lazy. It should tell you a bit more often to provide more information or give better questions, or like should push back a little bit more, just like the sales I was talking about, right?
Yeah.
It should push back a bit more. And you know the feeling where you're struggling with where you're working with an AI and it's sort of an output and it doesn't really make sense in what you were trying to do, and then you tune it and then it creates an output again, and you tune it and creates an output again, and every time it sort of misses the mark.
Yeah.
I think that has to do with it not being lazy enough, and we have to create an industry that's a bit more efficient from all levels of it, from the storage, but also from AI, but also for workloads, where most Kubernetes clusters, and I'm not expecting you to know what it is, but most Kubernetes clusters are like 20% utilized. That's not effective. It's not an efficient way of running an industry, but the IT industry has so much money because it has a power imbalance, right? It has a knowledge imbalance built into it, where it can ask a lot of money for pretty shoddy work sometimes. And that's something that's ingrained in there. Another thing that sort of intrigues me is like currently the large language model style of AI, the learning on data style of AI that we're mostly running. So far, I don't think it's proven that you can get smarter than the data you've trained on. So the limit would be our data. So the limit of its intellect would be basically how much data it can get from the best of us. And it is already more intelligent or more widely knowledgeable than a lot of people are, of course. But there's a really old short story that sort of goes into, they've been making this supercomputer for centuries. And the high priest, finally, after centuries of building this supercomputer that is supposed to be as smart as God, gets turned on, and the high priest can ask the first question, and it asks, "Is there a God?" And the answer is, "Yes, now there is." And lightning strikes down from a clear blue day and kills everyone around. That sort of scenario, I doubt that we're going to get there. And I don't think it can do something that we cannot. In the physics of our world, the laws of thermodynamics are fairly clear. I don't think it will be very, very easy to poke through something and find something that we haven't found.
It's interesting getting your perspective on this as somebody who understands the power and the infrastructure, because you were saying there's a real big gap that isn't actually perceived between the software experts and the power and hardware experts, right? Do you think that's why there's so much maybe like hype around it?
In a way that has to do with it, yeah. From a software point of view, it could be smarter than you and it could want harm on the world. But actually doing that, being confined to a metal box in a data center, will be pretty hard. They don't have opposable thumbs, We'll give AI opposable thumbs, it might start being different.
Does your opinion differ on robotics?
Yeah, but still, like that robot would need enough power,
right,
to run the largest large language model in the world. Okay. And currently running the largest large language model in the world requires hundreds of racks. Again, it would have to be connected, and it would need power, and unplug the power out of the data center, and that robot wouldn't be able to execute anything anymore.
Interesting. You're at a point where you've grown a team, and you want to do more of what you're doing and take it to the next level. What does that look like, and what are the bottlenecks?
Right now, I have this startup to finish. Once I have the feeling that the organization will be self-sufficient and I can leave it alone, and then it's time to move on and do something in that direction. But right now, we're on the cusp of it, but we're not yet there, and there's some details that have to be worked out, and then I can move to the next big challenge. What
do you want to do with this enthusiasm and knowledge?
Air conditioning, for example, is one of the biggest issues in the world. Yet technologies exist to cool a building using heat from the sun. But we don't have those at scale because they're slightly more expensive and they're slightly bigger than air conditioning.
Okay.
So there's so many industries where we can create massive jumps in efficiencies there's space radiating paint.
Space radiating paint?
Yes.
What's that?
It literally means you're cooling your building by emitting infrared to space, because space is cool. So yeah, this is possible. It's feasible. The technology exists. The paints exist. So we should probably lacquer big cities with this stuff, making sure that the buildings, first of all, don't get that much infrared heating from the sun in the first place, and second of all, cool themselves 24/7. So we're talking about a paint that if you take a metal sheet and you put it on it, and you'd aim it towards the sun in broad daylight, the panel would be cooler than ambient while in the sun.
Wow.
Passively. The reason for that is that it radiates infrared on a wavelength that goes directly to our atmosphere out into space.
What are the use cases for this specifically?
Well, every city in the world is currently dealing with massive heat waves because we've built brick everywhere, and we've built black roads everywhere, and we've built air conditioning everywhere that uses massive amounts of power to cool the indoor but heat up the outdoor.
Sure.
So yeah, building more effective and efficient cities would be something that's still interests me a lot, and I think there's tons of opportunity in that field. And there's also lots of money for cooling problems. There's lots of challenges that would like to be reached with that. So yeah,
I'd like to circle back round and kind of like pinpoint who it is you're looking to work with. Who is Leafcloud a good fit for?
We are mostly interesting for compute companies. So that means AI, but also computational fluid dynamics. So stuff like windmill energy forecast people, also Formula One, they use lots of CFDs, but as far as I know, they're very secretive. So might not want to work with us. Software houses and SaaS companies, software as a service companies, they generally tend to run on cloud, where we have both being much more cost effective, but also teaching their team stuff about infra that they wouldn't learn from the cloud center of excellence that Microsoft pushes forward. The other one is NGOs. NGOs usually do have some pretty hefty IT spend, and running on big tech has its own set of dangers for NGOs. So we do see lots of traction in that market as well. I think the main bottleneck is trying to sell to enterprise is complex and tough, especially in this market. We've been a bit too focused on that, I think, in the past 2 years, and I think we should refocus a bit on the sort of 50 to 300 people market where we do get better traction, and we talk to techies that like our product, that would deploy the workload, but they also are the ones responsible for the wallet in that sense, right?
Sure.
So whereas the techies in larger enterprises, they're usually not responsible for the wallet, but they are responsible for deploying the workload, and they're also not responsible for sustainability side of things. So in a lot of ways, you get to a point where when you talk to an enterprise, maybe the sustainability side of the company would love to run on you,
right?
But then they're telling it to software, and they're like, this is different than what Microsoft is doing. And I thought our cloud strategy was to do everything on Microsoft. So I don't understand right now. And they get like an internal struggle, and it takes ages for them to figure that out. So we really need to focus on clients that
have like smaller buying parties.
Yeah, smaller parties, smaller teams, where they understand the impact both on their climate emissions, but also on the pricing, because we're more affordable than big tech is, but also on a partner that integrates knowledge into their teams, how to use any cloud provider, how to be mobile. I think cloud should be consumed as if it's grain, right? There's different qualities of grain, and there's different prices because of the quality. But other than that, it's a very massive market where you just purchase grain, right? And cloud is that in a lot of ways, but it's been abstracted into becoming managed services and all kinds of stuff that if you have enough expertise in your team, you really don't need. You really don't need it. And you can run fairly easily on multiple cloud providers with tooling that is applicable to almost any massive cloud provider, tooling like Terraform, for example.
Okay.
And once you have a partner that actually teaches you stuff about that, you tend to see that they get more agile, get quicker to deploy their workloads, quicker to destroy their workloads. Very important for your costs as well, right? If you don't have a team that understands why every server they're running, you get zombie workloads.
Zombie workload. Unpack that for me.
That's a massive issue in the IT industry where a lead developer has left the company and they have workloads, but no one exactly knows what those machines are doing.
Right.
But they might be doing something critical, so nobody wants to touch it. So they exist, and no one knows why. And that's there's estimates of like 20% of all machines or virtual machines are zombie workloads.
Wow.
We do tend to teach our clients how to destroy workloads.
Okay.
Something that, of course, when you're looking at consumption, wouldn't be a good idea, but we're trying to do something good for the world as well. So, and at the same time, it's also something that's like, if you have those tools in your pocket to run everywhere and to create and destroy workloads more easy than you had before, that's something that naturally flows out as a result, that you're able to destroy workloads more easily.
Who would be like reaching out to you?
We tend to, in the end, sell to lead developers, CTOs, this level of company in companies.
How can they get in touch?
They can reach us at info@Leafcloud, or go to our website and make an account and just start a workload yourself. In this industry, a lot of times, people don't need hand-holding. We have good documentation. We use OpenStack, so it's really well documented. People can also just start themselves. And then if they need help with anything, we're there for them.
For companies looking to work with you, do you find that there's some hesitation or dread about how long it's going to take to migrate whatever kind of tech they're using now to be with you guys?
Yeah, there tends to be sort of this idea of, if you move cloud provider, you have to move everything. And I think that in a lot of ways, hybrid cloud is a very feasible and good solutions for lots of companies. So we want to try to search together with our clients and partners is we try to find like one workload that is fairly easy to move that one, and then create the trust and relationship that they need in order to go forward with more workload. And that's, I think, the core of it is we're working in an industry where usually big corporations purchase at a bigger corporation, right? And now we are a small organization selling to bigger corporations. So that balance has to be caught back up. We have to have a lot more to prove. And we do that by really helping them move the workload and then executing on that as quickly as possible.
Yep.
Making that feasible, making it cost effective. And we can do that. Proven we can do that. And then as they go along, year later, hey, look, this workload's still running there. Everything's good. Let's move that one too. Or this new thing we're doing with AI, let's move that. Let's develop our AI on Leafcloud and not on big tech, because first of all, it's ridiculously expensive to hire GPUs on big tech. And it's much more cost effective to do it us. And second of all, the sustainability impact is massive from the get-go. So if you move that workload, build that workload on us, then it's not stuck at big tech.
Let's jump now to what we call Quickfire Curiosity, which is our kind of short, just personal and fun trivia to end off with a few light questions. First of which being, would you consider yourself a futurist?
Yeah, I'm not one that says that the past was better. It's safer than ever. It's cleaner than ever. It's there's less child deaths. There's people get older. So I think that we're working on something big, and that's not ignoring all the things that go wrong. It's just looking at those things that go wrong in the point of view of the past where much more shit went wrong.
Having a sense of perspective, yeah.
We were, massively under the pressure of religion, and that had a lot of impact on our society. And so no, I believe that the future holds great things. We might need to have a talk about What are we aiming for? We are more efficient or effective than ever in terms of how much money we make per hour worked, etc., etc. But we never work less hours. We could probably work less hours, all of us, and have a better life. Go to the outdoor, hike, sail, bike, and enjoy life a little bit more. Take more time for that. But somehow we haven't gotten to that, and I think that's something we should start doing. And that's not lazy. It's a good way to live life. I'm not someone that thinks we're all green and the future is the best thing, but we are in a very real way creating a better future every day.
For people listening in that are considering a career in something around IT, renewable energy, or sustainability, what questions would you encourage them to ask themselves to identify the best opportunities?
This crossing of where infrastructure ends and software begins, I think that's a very interesting niche that I've found, where there's a big gap in information missing. When there is an information gap, there is also a power gap, and you can jump in and you can probably make good money doing something fun that tends to be rather important. Yeah. So things to focus on is understanding where power comes from, how it's distributed, but also understanding the software field, what they need and why they need it, and how large applications are run. Within those two, there's a big opportunity.
You're thrown back in time to see your younger self. You've got 30 seconds to give that young man who didn't sound like enjoyed school too much and wasn't given the tools to best use his creativity and intellect. What would you say to him to give him some encouragement and wisdom?
I'd say don't stress that much. It'll be all right. But you just have to go through this right now. Take your time, work on it, focus on what's important, focus on yourself, on your happiness. You'll find it. You'll find it when you get there. That goes for a lot of people, right? There's so much pressure on students and getting good grades, and in the professional world, especially in the IT field. How many self-taught guys that have like zero university, zero schooling are like running massive startups, massive organizations, because they're the best at what they do, is because they have experience from the ground level, especially in software. So many people that have absolutely no schooling that are better than anyone. So building on your own strengths and going from there, it's more important, and finding where your own strength lies. I think there's an interesting research about like hyper talent in sport.
Yep.
The best of the best, 0.1%, they tend to come from different sports than the ones they excel at. The 1% tends to be like the guys who started young and did tennis for all their life. But the 0.1% are the ones that played football and then they were playing tennis one day and are like, oh, I'm pretty good at this. I'm going to play some tennis on the side. And then it turns out they're massive talents in tennis. This, I think, applies for a lot of people. Like, don't stay stuck in one field where you think your talents lie. Try to find where they really lie.
David, thank you so much for your time today. Thank you for hosting us here.
Thank you for having us. Pleasure to meet you, and an honor in a way.
I believe we have a couple of bits of merch.
Do you have a bike, Luke?
I don't at the moment, actually.
You don't have a bike? That's a shame. We can get our bike sticker. This is for a bike frame. That's for drinking coffee.
Oh.
There you go.
Great. Look at that, everybody. We have props for future episodes. Excellent. Thanks for tuning in to this Amsterdam special of CleanTalk. It's been a pleasure chatting with David today, learning a lot more about technology. I'm climbing up a steep learning curve in knowledge, but it's been good fun, and I hope you've enjoyed it too. If you click to my right, you can click on other episodes of CleanTalk and content from Harmer Visuals, and we will see you very shortly in the next episode. Bye for now.